A .proto file by itself has, well, absolutely no power.
Yeah, it's really just a text file.
Exactly. I mean, it's a promise, really, just pure documentation. And it stays that way, totally inert, until a compiler actually steps in and enforces it.
Right. That's the defining line between a gentle suggestion and a binding mathematical contract.
Which is where the real magic happens. The moment this entire system gets its teeth is when protoc turns that shared schema into actual Python modules, Java classes, and gRPC interfaces.
Interfaces that both sides of your system are fundamentally forced to obey.
Right. Because, hope is a terrible system architecture.
Oh, absolutely.
Yeah.
Without that compilation step, you essentially just have two distinct engineering teams staring at a text file, just hoping their code doesn't drift apart over time.
And since you're out there bouncing between Python and Java every day, you already understand functions, classes, which leaves us with the how. How does that theoretical structure become native code that you can actually execute? We are unpacking that transformation from an abstract schema to real executable code. And to understand how one single schema becomes many different languages, we really have to look under the hood at the engine doing the translation.
Right. The core compiler, protoc.
And the architecture of that engine is brilliant because it splits the workload entirely in half.
It does. The first job of protoc is pure comprehension. It actually doesn't generate anything at first.
Oh, really? So it just reads it?
Yeah, it acts like a standard compiler front end. It reads your .proto text file, lexes it, and builds this incredibly detailed internal structured model.
Like an abstract syntax tree.
Exactly. An AST of what your contract actually means. It validates your field numbers, checks your types, and builds a complete map of your intentions in memory.
Okay, let's unpack this for a second. So protoc is essentially a standard compiler, taking a universal contract and emitting native build artifacts. So since protoc hands off the actual code creation to specific generators, let's look at what comes out the other end for the two languages you use every single day. Let's say we have a bookstore.proto file.
Okay, classic example.
We run it through the compiler targeting Python and Java. Let's start with Python. The output you get is designed to feel highly dynamic, right?
Very dynamic. Generating that file yields a Python file containing all the message classes from your schema, and they behave like native Python objects.
You can inspect them, print them.
Yeah, they feel flexible. The Python generator plugin deliberately avoids writing strict, rigid boilerplate because, well, Python developers just don't write code that way.
Good to know. So I can just ignore the PB2 name and focus on the behavior. Python gives us flexible modules, but Java is a totally different beast.
Completely different. Nobody wants to write Python-flavored Java.
Right.
So the output has to feel entirely different. Java outputs are strictly opinionated and heavily engineered. When you compile that same bookstore schema for Java, you don't get a dynamic module.
You get generated classes that are deeply, strictly immutable.
Exactly.
And the only way to build complex immutable objects in Java is the builder pattern.
Which is exactly what the Java plugin generates. Massive, highly detailed builder classes. You instantiate a builder, chain together your .setField methods, and then call .build.
And once that object is built, it cannot be altered.
Never. This is crucial because gRPC servers in Java are highly concurrent. You might have hundreds of threads processing requests simultaneously. Immutability guarantees thread safety.
Now, here's where it gets really interesting. Because Java is so strict, the code generation even changes how the files are physically laid out on your hard drive, doesn't it?
Oh yeah, the layout differences are night and day. Python just relies on the directory tree you invoke the compiler from, but Java demands everything perfectly match its package structure.
You actually have to put a Java package option inside your .proto file to dictate the exact namespace where the Java code lands.
You do. And you could even use Java multiple files to split top-level messages into their own individual Java files.
Rather than nesting them all inside one giant outer wrapper class.
Exactly. But regardless of whether you split the files in Java or use dynamic modules in Python, the bytes sent over the network, the actual data moving between the services, is identical.
The wire contract is absolute.
The serialization format never changes. Code generation merely changes how comfortable the code feels when you interact with it in your specific IDE.
Okay, so we have these native Python modules and these massive Java builders. But right now, they just hold data. They are the nouns of our system. Nouns are great, but applications need verbs to actually do anything. What happens to our generated code when we add a service block to our schema?
Adding a service block triggers the next distinct layer of compilation. Message generation is only half the pipeline.
Okay.
When protobuf sees a service, it invokes the gRPC plugin. And that produces a completely separate set of generated artifacts layered on top of your messages.
So the protobuf messages define the data, and the gRPC artifacts define the network behavior.
Precisely.
What do those gRPC artifacts actually look like?
Well, in Python, you get a companion file. Alongside your pb2.yy file, you get a pb2gRPC.py file. This contains two vital pieces. First, the client stubs.
Which act like local methods you can call?
Right, but under the hood, they serialize your Python arguments into bytes and shoot them over the network.
And the second piece?
The servicer-based interfaces. This is what your server code will inherit from. It handles the reverse, taking incoming bytes off the network, turning them back into Python objects, and passing them to your application logic.
And Java follows the exact same conceptual pattern, right?
It does, but it generates a new class, typically appending gRPC to your service name. So like BookstoreGrpc.
Got it.
Inside that class are your Java client stubs and your server-based classes.
Okay, let's say I have all these files generated. I'm deep in a debugging session. I'm looking at the generated Java client stub in my IDE, and I notice it's failing to connect under a very specific condition.
Okay.
I just want to add a quick print statement inside the stub to see what data is passing through. Or maybe I want to tweak how the stub handles a timeout. Can't I just patch that generated Java class directly? It's just Java code sitting right there in my project directory.
I cannot stress this enough. Absolutely not. Never.
But the file is right there. My IDE is begging me to refactor it.
The temptation is immense, I know, especially when the generated code looks like normal Java or Python. But that violates the golden rule of this entire ecosystem. Do not edit generated code by hand.
Because they're pure build outputs.
Exactly. Think of them like compiled .class files or .o binaries. If you patch that Java class, the very next time your continuous integration server runs, or a teammate, recompiles the schema.
My print statement is instantly erased.
Overwritten without warning. Gone.
Because the schema is the only true source of truth? If the generated code is just a disposable artifact, then any custom logic I write has to wrap around it or inherit from it.
Yes. You can never modify the output itself. If you need a change in behavior, you must change the .proto file and regenerate. Handwritten application code lives in one folder. Generated artifacts live in another.
A rigid firewall must exist between them.
Always.
Okay, and knowing exactly where this code comes from and why it is structured the way it is sets us up perfectly for our next chapter.
Chapter 5.
Yes. Now that we have our client stubs and our servicer interfaces generated, next time we're actually going to use them. We will write the application code to spin up a server and walk a real, live, unary call from the client to the server and all the way back.
Moving from the theoretical schema into a live running system.
I can't wait. Until then, keep your schemas clean, master your toolchain, and keep your generated code strictly off limits.